Have you ever watched a rocket launch and just been completely mesmerized? I mean, how does something that massive, just an enormous tube of metal, actually get off the ground and fly? Well, today, we're going to crack that mystery wide open. And the secret? It's not some super complex futuristic technology. It's actually just three simple but incredibly powerful rules. Let's get into it. I mean, really think about it. You have this colossal machine weighing millions of pounds just sitting there. And then with all this fire and thunder, it just goes up, straight into space. How on earth is that possible? Well, the answer has actually been around for centuries, thanks to a guy named Isaac Newton and his foundational laws of motion. So our first clue in solving this whole thing is Newton's first law of motion. It's officially called the law of inertia, but I like to call it the law of the stubborn object. You'll see why in just a second. So what does that actually mean? Well, put simply, things like to keep doing whatever they're already doing. If something's not moving, it wants to stay not moving. If it is moving, it wants to keep moving at the same speed and in the same direction. It's kind of lazy or stubborn, right? It won't change what it's doing unless some outside force comes along and makes it. You experience this all the time. A football sitting on the grass isn't going anywhere until a player, that's the external force, comes along and kicks it. And we've all felt this one. You're in a car, it hits the brakes hard, and your body lurches forward. The car stopped, but your body, because of inertia, wanted to keep right on going. And yeah, that's exactly why seatbelts are so important. Okay, so what does this have to do with our rocket? Well, this is a huge deal. Once the rocket is out in the vacuum of space, where there's almost nothing to slow it down, it doesn't have to keep its engines firing all the time. Thanks to inertia, it can just shut them off and coast forward. It's what makes traveling across the solar system even possible. But that only explains what happens when it's already moving. How does it get off the ground? For that, we need clue number 2. Right, so inertia is great once you're in space, but it doesn't help you one bit when you're stuck on Earth's launch pad. To understand that, we need to look at our second clue, Newton's second law. I like to call this one the big push. You've probably seen this one before, maybe in a science class somewhere. F equals ma. It's a really simple formula that tells us something profound. The more massive or heavy an object is, the more force you need to apply to get it to speed up. Just to give you an idea, the Saturn V rocket, it needed to generate over 7.5 million pounds of thrust to lift off. That's like the power of 160,000 cars all flooring it at the exact same time. This chart here really breaks it down perfectly. Imagine you take the same exact engine and you put one in a small car and the other in a huge, heavy truck. Well, that small car is going to accelerate way faster, right? That's because the truck has so much more mass, so it needs a much bigger push to get going at the same speed. And this gets us right back to the rocket's #1 challenge. It is just incredibly massive. So to accelerate it upward, fighting against the pull of gravity, its engines have to generate an absolutely enormous force. We call that force thrust, and it has to be way, way bigger than the entire weight of the rocket. Okay, so we know a rocket needs a colossal push. But here's the real head-scratcher. What is it pushing against? There's no ground to push off of in the air, and certainly not in space. The answer is our third and final clue, and it's a principle that is just so beautifully simple. The law of action and reaction. This law is so cool. It basically says that forces never exist on their own. They always come in pairs. So whenever you push on an object, that object is pushing back on you with the exact same amount of force, just in the opposite direction. One is the action, and the other is the reaction. And this is happening everywhere. A basketball player wants to jump. What do? They push down on the ground with their feet. That's the action. The ground then pushes up on the player with that same force. That's the reaction, and it launches them into the air. It's the same with a car. The tires push the road backward, and the road pushes the car forward. And this right here is the absolute core secret of how a rocket flies. The action is the rocket's engines blasting hot gases downward at incredible speeds. The reaction is those gases pushing the rocket upward with an equal and opposite force. The rocket isn't pushing against the launch pad or the air. It's literally pushing against its own exhaust. How amazing is that? So there we have it, our 3 crucial clues. The stubborn object, the big push, and the equal opposite. Now let's put them all together and solve this mystery once and for all. So here's the whole picture. Law number 3, action-reaction, is what provides the liftoff. Gases go down, rocket goes up. Law number 2 tells us how much force is needed, a gigantic thrust to overcome the rocket's gigantic mass. And finally, once it's out in space, law number 1, inertia takes over, letting the rocket coast through space without constantly burning fuel. It's a perfect system. So you see, the big secret of rocket flight isn't some special rocket rule at all. It's the exact same set of universal laws that govern everything, from a kid throwing a baseball to the way planets orbit the sun. It's the basic language of how everything in our universe moves. So the next time you see a bird take flight, or a boat moving across the water, or even just when you take a step forward, you can remember these 3 laws. You now understand the deep physics of what's happening. So the real question is, what else are you going to see now that you know the secret?